There's 3 unknowns. So y'all, a natural number is a number like 1, 2, 3, 4, 5. It's the non-negative, or it's the positive integers, the positive integers. So in other words, 0, x equals 0, y equals 0, z equals 0 cannot be solutions here. So if we just tried to guess and check, we wouldn't have much luck here. We might get a few solutions. So we need to use a little idea that allows us to factor this expression. It's something I wasn't familiar with till maybe 6 months ago. What we do here is actually force a binomial factoring circumstance by, first thing we do is very straightforward. We just factor out yz from both terms right here, and that's this step right here. Now, the very next thing to notice here, and to motivate this trick, I guess you would call it, 1 plus x is a binomial factor here. So if we just add 1 to this x, we get 1 plus x as a binomial factor occurring in 2 places, which means we can factor it out. The price we pay is we have to add 1. We had to add 1 right here. So 142 plus 1 is also 143 when we add to the other side. Okay. And so anyway, we get this expression, and we have a factored form that's equivalent to the original equation, which makes it, we'll know when we're done here. Now, so what we're going to do right here is just look at the possibilities. If you take a look at the first possibility, 143 is almost a prime number. It's equal 143 and 1 are the factors of 143, and also 11 and 13. Now, if you'll notice right here, there's going to be no solution for both this case and this case. And the reason is to solve this equation, x would have to be equal to 0, right? And to solve this equation right here, the product yz would have to be equal to 0, which it can't be since we're looking for natural number solutions. Okay, so we actually we're done as far as this very first step. Now, the very next one's a little more interesting. Notice that right here, for this to be true, x would have to be 10. All right, for this very first condition to be true. We're just equating factors with the factors or divisors of 143. Okay, so we know that 10 for the x coordinate will create 11 right here, right? Now the part, we can do this by inspection, hopefully. We need for 12 to be right here. So 12 factors into 1 times 12, 2 times 6, and 3 times 4. So I'll put 112 here. Okay. And folks, again, you can see this is the x coordinate, the y coordinate, and the z coordinate. And we needed a 12 right here. So 1 times 12, or y times z, is 12. 1 plus 12 would be the 13 right here. Okay. Now, in a similar fashion, another ordered triple solution. And I should say you can write this in reverse order too. I'll put a little, just to save the writing here, we'll put the double arrow right here. We could also say 12, 1 would be another solution. So there's actually 2 solutions here, 10, 1, 12, or 10, 12, 1. Now let's look at, I guess 2 and 6 are going to get it done also. All right. And also 3 and 4. Okay, so I think I got room here. Yes, I do. Or say, so we have 10, 3, and 4 for the x, y, and z coordinates. Okay. Again, I'm doing this by inspection because the calculations are pretty easy right here. Again, 3 times 4 would give us a 12 right here. 2 times 6 would give us a 12 right here. And of course, 1 times 12 would give us a 12. Okay. And there are actually 6 solutions here. The x and y's can be transposed. All right. Now, right over here, in a similar fashion to what we just did, we need x to be 12. See, y'all, what I did, I just swapped the 11 and the 13 because the order does matter here. So 13 and 11 got swapped, and that means that possible solutions for this guy right here would be, come up here, 12 for your x coordinate. Okay, now the only possibilities, we need y times z to be 10. So 1 plus 10 will equal to 11, right? So we can do y equals to 1, z equals to 10. And just like before, I'm going to go ahead and use the little arc arrow right here to let you know that we could reverse the positions of those two values. Okay, so you got this going on here like that. Okay. So those are solutions. Now, the only other factorization of yz that would give you 10 would be 2 times 5. So right underneath here, I'll write 12. And then 2, 5. Yeah, that's it. Yeah, I'd like to point out that Wolfram Algebra, the computational engine that everybody trusts a lot, left out some of these solutions. Like it didn't even include the solutions with 12. And I think it left out one of the solutions here. It may be because I'm using the free version of it, but I double and triple checked. And guys, you can go back in and check these values. For example, if you put 12 right here, you get 12. 12 would be located what, right there? Okay, and then I'll just do one of them. And then now 2 times 5, that's your YZ coordinates. That would give you 10 up there, right? Okay, y'all, this stupid thing's getting in the way of what I'm trying to do here. That would be 10. Okay. All right, and then 12 times 2 times 5 is 120. And I'll write it right there. So that's a check on one of them, right, folks? 120 plus 10 plus 12 is 142. 12 plus 10 is 22. 22 plus 120 is 142. So there you have it, folks. And I would want you to know there are 10 solutions here, actually. 1, 2, 3, 4, 5. And then since you can reverse the y's and the z's, there's actually 10 overall solutions. 10 solutions. You know, this is called completing the product. Simon's favorite factoring trick. SFFT, it's abbreviated that way on the web. All right, hope you enjoyed.